Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 15th February 2023. The problem statement for today is Geeks Island. This problem is based on depth first search concept of graph. So let's now open this problem. So first we will go through the problem statement clearly. Here it says Geeks Island is represented by an n into m matrix that is called and that variable name is mat. This the island is touched by Indian Ocean on the top and left edges and the Arabian Sea from the right and bottom edges. Okay, so on the top and the left side we have Indian Ocean, on the right side and the bottom side it is surrounded by Arabian Sea. Okay, each element of the matrix represent the height of the cell. Okay, due to the rainy season the island receives a lot of rainfall and the water can flow either in four directions: up, down, left or right. Okay, from one cell to another with height equal or lower. Okay, so that is the normal phenomenon of water flowing. The water will always flow from the higher to lower or to the equal surfaces, the surfaces of the equal heights. So you need to find the number of cells from where water can flow to both Indian Ocean and Arabian Sea. Okay, so here we need to find, we have been given this matrix. So each of this cell represents the height of a particular place on that particular island, and we have to find all those places on the island or the cells from where water can go either to bottom and left or right or up or any side. That means the water should flow to both the water bodies, whether it is Arabian Sea or the Indian Ocean. So here the explanation also they have given something like that. So here with this input, the output here it is 8. How we have got 8, that we will try to understand. So here they have just try explaining by drawing some diagram. So this represents this tidal symbol represents the water bodies. So that is the Indian Ocean and the star is the Arabian Sea. So on the left side and on the top side it is surrounded by Indian Ocean, and on the right and on the bottom of the island it is surrounded by Arabian Sea. So here it is said water can flow to Indian Ocean. Water can flow to both ocean and sea from the cells denoted by the parentheses. Okay, so all these cells, it is said that water can flow to both the oceans and the sea as well. For example, at index 1 2, row number 2, that means 6. It is saying about this example 6. The height of the island is 6. Okay, if the water drop falls on the island, water can go to the up direction. Here, yes, it can go to the up direction because this 6 is more in height than 3. So water can definitely flow from 6 to 3. So yes, it can definitely go up in the upward direction and reach the Indian Ocean. Yes, from this side it can reach the Indian Ocean. Also, water can flow in the right direction. Here, from here, water can flow to the right direction. Yeah, here also we can see that to the right of 6 we have two cells of 4. That means both the cells are lower in height than the current cell. So yes, again water can again travel in the right direction. So from 6 it will flow to this node, this 4 cell. Again after that it can again flow to this one, and finally reach the Arabian Sea. So that way it is said that 6 is one of the answer. So from there it can flow to both Arabian Sea and Indian Ocean. So similarly we need to find all the cells from where water can flow to both the water bodies. So we'll try understanding one more example. Let's take the example of this 7. So from 7 we can see all the cells to the top of it, that is smaller in height. So water can flow in this direction, reach Indian Ocean. Water can even flow this direction from 7 to left and it will reach Indian Ocean again. From 7 to Arabian Sea it will flow through 1, which is again lower in height, and from say 7 to towards, if it moves towards the right direction, then we can see all the cells are lower in height, so it can go to Arabian Sea through the right direction as well. So here through 7 it can flow in all 4 directions and reach both the bodies. So similarly we need to find, that means for each cell what will be that will be part of our resultant, we need to find at least one way through which the water can flow to Indian Ocean or the Arabian Sea. So here what we will do that, so here instead of we finding the cell, that means if we are currently iterating through this matrix and suppose we reach 7, then or we reach this 6 only, whatever it has been given in this example, if we reach by 6, then instead of after reaching 6 we keep on checking that all the cells to the left of it is smaller than 6, or to the top of it is smaller than 6, to the right of it is smaller than 6, to the bottom of it is smaller than 6. Instead of doing that, what we can do, for Indian Ocean we can start with this cell, that means cell of 0 0, and we can see is it satisfying the condition that this particular cell, that means this is the current cell in reference, this is lower than the neighbor cell. So if it is lower in height than the neighboring cells, then only water will flow from that neighbor cell to itself. So since here 1 is smaller than 3 and 4, so if water droplets has to flow from 4 to 1 and 3 to 1, then that will be possible because 1 is less than that. So once this is done, that means if we get up to this one and we check the condition, either yes 3 is more in height, so water can flow from 3 to 1, then we will increment our counter, our that J value, and we can reach here. Now after reaching 3, we will check again the same thing. Is it smaller than the neighboring cell or equal to the neighboring cell? Then yes, it is smaller than the neighboring cell. Then we will again move it here. So I hope you are getting it. That means instead of after reaching a node and we are looking in all 4 directions, we'll start from this one for Indian Ocean, and for Arabian Sea we will start from this last index one, and here again we will check for Arabian Sea if this 4, that means this particular cell is smaller than the neighboring cell. See, if you take this example, if any water droplet falls on this cell, then from here, from this cell, it can directly flow to Arabian Sea through downward direction. That is very easily possible, but it cannot flow to Arabian Sea by traveling to the right direction, because after 3 the height here is more. So water droplet cannot travel from lower height to top to a place to the higher height. That's why we will keep checking that if whatever the cell we are checking in reference, if that particular cell is lesser than the neighboring cell, if it is possible, if it is lesser, then we can assume that yes, from that particular neighbor cell water can flow to this cell, and from there onwards to the Arabian Sea. So taking this approach we will in mind only, let's start coding for this. And wherever we reach any cell that yes, the neighboring cell is more in height, then we will mark that particular cell as that visited. Yes, that for Arabian Sea water can flow to Arabian Sea from 5 4, so we will mark both these things. So now we will create one set of nodes from where water can flow to Indian Ocean, and another set of nodes from where water can flow to Arabian Sea. Now once this is done, then what we will do, we will just try to see in which case, that means for what all cells it is what to say, we can say an intersection, that means intersection of both the set. That means what all cells are there from which is present in both the set. That means from that cell water can even flow to Indian Ocean or to the Arabian Sea. So whatever cells are common in both the set, that will be our resultant. So we'll just count that number and we will just return that. So that will be our output. So here that whatever it is shown in bracket, that's represent that from all these nodes water can flow in both the water bodies. Okay, so now let's start coding for this. So here we can create a matrix saying we'll create two matrices here, one for ocean, that means that is for Indian Ocean, that is new boolean of n m, and similarly we will create another matrix here, it will be C. Let's write it in a smaller letter. So first we are creating these two matrices, and see we are creating these two matrices to mark that which all cells have been visited and from where we are getting that particular condition true, that water can flow to either of the water bodies. So this ocean cell will contain this matrix will contain all the cell information from where the water can flow to Indian Ocean, and this cell matrix contains all the node information from where the water can flow to Arabian Sea. So now once this is done, then we can start traversing the entire graph. That means this matrix there, starting with int I is equal to 0, I less than n, then simply increment this I plus plus, since we have this 2D array, so we need second iterator also, saying j less than, this will be m. So one is for a row, that means I hope this is very clear, that means n is the row here and m is the column name. So I is referring to row and j will be referring to column. So this is the usual thing which we do in all the questions whatever we try to solve, so that is very normal thing. So now once this is done, so what we can do, we can call a method find cell, something like that. So we will start our search operation here. What we will do, search operation, we will pass here the indexes of ij, then we will pass the matrix here, just for comparing it with the neighboring node by incrementing the value and still restoring the original index. I will pass the ij again. I'll explain it while I'll write this method. That time it will be more clear that why this has been passed twice. So this search is done. So what I said that see, first we are doing for the ocean, and ocean I said that I'll be starting for ocean with this node, and for Arabian Sea I'll be starting with this node. That means instead of going to a particular node and seeing all the surrounding cells, we'll start with this one and just compare if it is smaller than the next subsequent neighbors, next neighbors. So that's why, so I'll start with this one when if I is equal to 0 or j is equal to 0. That means if I is equal to 0 or j is equal to 0, that time we will start this operation here. So what we can do, just close this in a bracket. Okay, now this is for the ocean. That means we are finding cell for the ocean. Now what we can do, now we have to find for the sea as well. So here what we'll do, we'll start with this cell. So what is this one? This is n minus, what happened? n minus 1 or j is equal to the corresponding column one, that will be m minus 1. So here again we will be passing the same thing. Here instead of that particular node we will pass c here. Okay, so now we are finding our cells, and each time, that means inside this method only, we will update this matrix which we have created, and at last we will see, that means what are the common cells present in both this matrix. So for that, first I need to create, I'll create this one where this method is ending here. Okay, so let me write after that. So I'll write here find cell, and here I'll accept all those parameters that have been passed from the above. Here it will be int of and the variable, let's keep it same. Here int, we can just give some different name. We are passing same ij here, but this one, while receiving two local variables, cannot have the same thing. Here we cannot have ij declared twice, so just give some different name, int v, then boolean array, and just give this name as visited to get the input of this ocean and sea matrix. So once this is done, so now here we have to perform our major operation. So what first we need to see, we will negate first we will write the negative scenarios, that means where we cannot proceed. So in which scenario we cannot proceed? When I becomes less than 0. Okay, then we cannot proceed, or j becomes less than 0. See here now the question might arise that why we are checking for I less than 0 and j less than 0, because we are starting with I j is with 0 0 and will go up to n. But here we need to even consider that if you are at any particular node, then we have to check in all four directions. That means at that moment we need to increment the value of j, even decrement the value of j. Same will happen for I also. So that's why this check is there. It will be more clear once I complete the code. So and here it will be matrix.length I, or if in case if I is going ahead of matrix.length, then also that will be our negative scenario. That means we cannot proceed more than that. And if j becomes greater than matrix of 0, that means for each row, what is the length of the column in that one, so it cannot exceed than that. And in other case, if that particular cell is already visited, if it is already visited, that means that has already been considered, then we do not need to consider it again. So here we can simply return. So this we have checked one scenario. Another scenario which we have to check, that we have discussed while discussing about this example solution. So if at any moment if matrix of u v, if that becomes greater than mat of I j, then here also return. See, this is very important step. So here what I've decided, that first we will start with this one, then we will check if this continues to be lower or equal to the neighboring cells. If it happens, then then it is well and good. But if you are keeping hold of this particular node, and if it happens that if it becomes greater than the neighboring cell. So suppose we are at this 4, then if we compare it with this 4, this 5, we are at this 5, and we compare it with this 4, then this 5 becomes greater than this one. So that time water cannot flow from 4 to 5. So that time we will mark this as return. So this is for that purpose only. We will update this value of I and j in each iteration, and we will compare with the previous one. So this will become the updated value, updated cell, and this becomes the previous cell. So it will, I'll just check that if previous cell value is still lesser than or equal to the next cell value. If that is true, then yes, so we can proceed with that. But if it becomes greater, then we have to return from that moment only. So these two are our negative scenario. If these two are not there, then now we can mark visited of I j as equal to true. So here this check was there, that if it was already true, then we were simply returning. But if this was false, then we are marking it as true here. Now here it comes the important thing here again. Now we need to call this this method in a recursive way, so that whatever we have operation we have performed till here, we can do for all the neighboring cells. That means if you are at this moment, then we can do with this. Once we reach this, then we can perform with the neighboring cell. If you are at this, then we can perform with this. Similarly in all 4 directions. If we are at this 5, we need to check with this, with this, with this, with this. So we need to find all those combinations. So for that, what we need to do, we need to call this method find cell again. Here what we will pass, we will pass the I again, but here now instead of I, now we will move in right direction. So how we will move in right direction? We have to keep the row number same, that is I same, but j will become j plus 1. Now we will pass a new j, that is will be j plus 1. Here matrix will be again mat, that will be same, and here we will again pass I and j only, so that as I said here in this one, this ij whatever we are getting here, this will be pointing to the neighboring cell. That means the new cell which we are looking to, but this uv will point to the original one, that means the current one in reference. So that we are again passing that ij only, and here again we are again passing the visited matrix again, so that it can even check for the all the neighboring nodes in the right direction, and it can mark whether it is visited or not. So this same operation we need to perform in all 4 directions. So I'll just copy paste this 4 times, then I'll change the value. So so in this one we move to the right direction. If we have to move to the down direction, that means j will still be the same, the column will still be the same, but row number increases. So here we will check in the downward direction. So at any moment, so right now from 1 in the first step from 1 we checked 3, but if you have to check 1 with this 4, then we have to move in the downward direction. So what happened here? Column number remains same, but row number increases. So that's why I am checking in the downward direction. This I plus 1 will indicate in the downward direction. Same thing if we have to move to upward direction. So what we can do, for downward it will increment by 1. So if it but in upward direction we have to decrement by 1, and j will still be here j only, because we are again just moving upward from 4 to 1. So here the row column number will be same, but row number will be decremented by 1. And for the last one we have to move in the left direction. So how to move in the left direction? Column number should decrease here. So if you are at 3, then we need to at any, that means I'm just giving a reference of these 4 nodes, but yeah, it can be at anywhere in this matrix. So if we are at any current position, we need to check for the neighboring node on the left side, then what we can do, we have to keep the row number same but decrement the value of column, so it will be moved to this one. And this new updated thing, I'll just explain again. This new updated thing will be pointing to the next one, next node which we are trying to take into consideration for comparing. But the current cell where we are in, that will still be pointed by I and j only, which is also getting updated with each iteration. But yes, but for the next comparison, we will be just passing that updated value from here, that we will get it as here. So now this is done. So now we have updated. Now since we are calling this one for both ocean and sea, so we will get all those values populated from where water can flow to ocean and sea. So and all those values are stored in this one. So what we need to do now? Now we need to check. We need to check, that means what all cells are common in both these things. Okay, so here what we can do, here where this is getting closed. Okay, so here we can just what are the return type here? Return type is integer here. So here integer of just giving some variable name, number of cells 0. Now just the same for loop. Let me just copy it. Why to write it again? Control C, because we'll be just checking the values of those two matrices there, so no point in writing it again here. So here I is equal to this, I will go up to n and j will go up to n. Here we'll just check if ocean of I j is true and C of I j is also true. If this is the thing, then what we can do, number of cell plus we'll just increment this counter number of cell. So here we are checking if for a particular combination of I and j, if both if a particular cell in both ocean and sea matrices are true, then that will be our scenario. That means ocean matrix contains all the cells from where water can flow to Indian Ocean. And similarly, this C's matrix contains all the cells from water can flow to this one, Arabian Sea. But if there are some points where there are some combination of I and j where both these matrices are true, that we can consider that these are the particular node which we are looking for. That means from these particular cells or nodes, water will flow in both the water bodies. So once this is done, so where this is getting closed, here, so we'll return number of cells. So yeah, that's it in this coding. So let's try compiling this code. I hope everything goes well. Not that easy also. What is saying? Return type. Okay, sorry, though we are not returning anything, we need to return, just mention it is the return type is void. Okay, oh shit. So something, find cell line number 60. If I less than 0, matrix dot length, this array index out of bound for 5, line number 68. Okay, here we have to give equal to, because it can go up to that length. It cannot go beyond that. It's okay. Okay, so here we can see we have got this got the output for this given input here. So now let's try submitting this solution. Okay, so here we can see we have got all the test cases passed. So we have solved this problem successfully. Yeah, so that's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.